Hello and welcome. In today's video, we are going to be solving some of the basic integrations problem. So the first thing that I recommend you doing is to get familiar with the basic rule of integration. But in this video, we are going to go over some, especially the constant rule and that of the power rule. So for example, if you have the integral 5 dx, this is going to be 5x plus c. If you have the integral 5 t dx, we are going to use the power rule. That is going to give us 5 t, the power of t here is 1, plus 1 over 1 plus 1. This is going to give us 5 t raised to the power of 2 over 2. So the power rule says that if you have a variable raised to the power of n, you are going to add 1 to that power and divide by that power plus 1. Alright, so in this case, u here is the variable t, and 1 here is the power of t, and this one is what we added to the power. So let's get our first example. Let's say if you have the integral of s squared, x raised to the power of 4 minus s raised to the power of 3 plus x raised to the power of 2. By using the power rule, we can say that this is going to be x raised to the power of 4 plus 1 over 5 here minus x raised to the power of 3 plus 1 over 4 plus x raised to the power of 2 plus 1 over 3 plus the constant of integration. So now we can add the powers. The final answer is going to be x raised to the power of 5 over 5 minus x raised to the power of 4 over 4 plus x raised to the power of 3 over 3 plus the constant of integration, c. So the next problem, let's say if you have the integral 5 t raised to the power of 8 minus 2 t raised to the power of raised to the power of 4 plus t plus 3. You can say dt. All right. If you like, you can separate all this set into different integral or a separate integral like this. If you can say the integral of 5 t raised raised to the power of 8 minus the integral of 2t raised to the power of 4 plus the integral of t plus the integral of 3. Alright, and forget to add a dt, 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 here dt. Right. So now as you can see, we have separate integrals. We can also use the power rule on the first one. That is going to give us 5 raised to the power of 5t raised to the power of 8 plus 1 over 8 plus 1. And the next one here, we can also use the power rule, and that is going to give us 2t raised to the power of 4 plus 1 over 4 plus 1 for simplicity. And the next one here is t, so that is going to give us plus t raised to the power of 1 plus 1 over 1 plus 1. And lastly, we have a constant that's going to be plus 3t plus the constant of integration. So now again, we can simplify by saying we're going to have 5t raised to the power of 9 over 9 minus 2t raised to the power of 5 over 5 plus t raised to the power of 2 over 2 plus 3t plus the constant of integration. So this is the final result for this. So let's get another problem. Let's see if we have the integral uh, 7 I use a variable x raised to the power of 3 over 2 plus 2 x raised to the power of 1 over 2. You can say dx. So integrating this one, we can also separate it into separate integral by writing it this way. The integral of 7 x raised to the power of 3 over 2 dx plus the integral of 2 x raised to the power of 1 over 2 dx. Right? We can also apply the power rule on these two as well. That is going to give us, we can bring this 7 across here. It's going to be the same. That's going to give us x raised to the power of 3 over 2 plus 1 over 3 over 2 plus 1 plus, you can also bring it 2 across. here, integral of x raised to the power of 1 over 2 plus 1 here divided by 1 over 2 plus 1 here. So we can simplify this expression. Here is going to be x raised to the power of 5 over 2 over 5 over 2 plus 2 x raised to the power of 3 over 2, because 2 times 1 is going to give us 2 plus 1, that's going to give us 3 over 2. So now we get 3 over 2. We can simplify this further. Since we have a fraction here, and this can also be written as, we are going to multiply this by s of 2 here by 5, then multiply this with 2 here because you are switching, plus 2 x here raised to the power of 3 over 2 times 2 as well. So the final answer is going to give us 14 x raised to the power of 5 over 2 over 5 plus 4 x raised to the power of 3 over 2 over 3 plus c, which is a constant of integration. So thank you very much for watching this video. I would appreciate you subscribing to this channel because it is a new channel. In the next video, we are going to cover more problems with the product rule and as well as some complex problem too as well. So I look forward to seeing you in the next video. Thanks for watching.